Hello everybody, welcome to today's lecture. Today we are going to discuss about chain rule. So chain rule is a familiar topic in one variable, and it goes with, we start with an example first. So let us suppose that y is equals to sine 1 by x. So here we see if we need to find the derivative dy by dx, so what we do is first we denote 1 by x as some u, and so what we get is y is equals to sine u, and here and u is equals to 1 by x. So here what we do is, to find the derivative with respect to x, we do dy by du and again du by dx. So how it goes, we have dy by du is sine u differentiation with respect to u, so it becomes cos u dot du by dx. So we differentiate the function u with respect to x and we get minus 1 by x square, and hence we put the value of x and we get minus 1 by x square dot cos 1 by x. So this is the way we use chain rule in one dimension. So let us see the definition for one dimension. For a differentiable function of a single real variable f of u, if u is equals to ux is also a differentiable function of u of x, then we have the familiar chain rule df by dx is equals to df by du dot dx by du by dx, as we have done here. Now we extend this concept to two dimension. So for two dimension it goes on with, suppose that f of x uv is a differentiable function of two independent variables u and v, which in turn are differentiable function of one independent variable x. Then f is differential function of x, and with the help, and we have the extended chain rule, namely del f by del x is equals to, similarly as this, but we have two variables, so del f by del u by del x plus del f by del v by del x. Similarly, if we have in the same way, let us consider the function f of uv, which is a differentiable function of u and v are differentiable function of x and y. So in the previous, what we had was f was a function of u, v, and uv were function of x alone. So what we did was, we need to find with respect to one variable, and it was del f by del u by del x. First we partially differentiate this, and again we get del f by del v by del x. But now the second condition is, we have function which is a function of two variables uv, and uv is also a function of two variable xy. So in this case we need to find the partial derivative, and the partial derivative will follow as del f by del x is equals to del f by del u by del x plus del f by del v by del x, and similarly del f by del y, del f by del u by del y plus del f by del v by del y. You see, we can't proceed because f is a function of u and v, so we can't proceed directly to x, so we take the path del u and del v in between. So this is for two independent variables, and in this case df, which is the total differential, is defined as del f by del u du plus del f by del v dv. So let us try to understand this by an example. So here, consider the function f defined by f of uv is equals to uv. So root over uv, and here uv in turn is u is equals to x and v is equals to x. So uv both are functions of x. So here we need to find del f by del x, and as we already know, the formula is del f by del u by del x plus del f by del v by del x. So we need to find del f by del u and del f by del v. So now, if x is equals to 0, in either case, if x is 0, then what we see, u will be 0 and v will be 0, and hence the function will also be 0. If the function is 0, then its partial derivative del f by del u, del f by del v will also be 0, and in this case we will have nothing. So thus when x is equals to 0, we get del f by del x, which is equals to del f by del u and del f by del v, which is 0, so we get 0 plus 0, which is 0, right? So now let us see, put the value when x is not equal to 0. Suppose x is some x which is not equal to 0. So what we get is the function f of x comma x will be root over x whole square, which is modulus of x. And we know that del f by del x will be plus 1 or minus 1 according as x is positive or negative, because we know del x by dx by dx will be 1, but we have modulus, so it will be either plus 1 or minus 1. So we'll have two values of the differential which is not possible according to our definition of differentiation. Hence this differentiation df by dx does not exist when x not equal to 0. Let us see another example. A plane polar coordinate system. In plane polar coordinate system, what we have is Cartesian system r theta are given in terms of rectangular Cartesian coordinate system xy by the equation. So we have the equation r is equals to root over x square plus y square, and the other is theta is tan inverse x by y. So y by x, we are familiar with this thing where x is greater than 0, y by x. So let us check for the differential. We need to find the total differential. So when we take d differential in this, so dr will be x dx plus y dy divided by root over x square plus y square. It's simple. Let us see how the mechanism works. So this is dr is equals to, when we differentiate this thing, so this side is dr and here root over x square plus y square. So root over x square plus y square is x square plus y square whole to the power half, right? So when we differentiate, we'll get 1/2 here, and this will be minus 1 dot. We need to differentiate this partially, differentiate this. So this is 2x square 2x dx plus 2y dy. So what we get is half 2 common x dx plus y dy whole divided by root over x square plus y square, and this cancel, so we get this result. Similarly, when we differentiate this, del theta is equals to, we will get x dy minus y dx divided by x square plus y square. So now, since x and y are independent variables, so we can write, so what we can write is del r by del x. So differentiating this with respect to x, which is x root over x square plus y square. So see here what we get is, we differentiate r with respect to x, partially taking y as y to be constant, we get this, and this is x by r. Similarly, del r by del y is equals to y root over x square plus y square, which is equals to y by r, and in the similar manner we get minus y x square plus y square, which is equals to minus y by r square, and del theta by del y is equals to x square plus y square, which is r x r square. So this is how we find the partial derivative. We now define it for 3 dimensions. So for functions of 3 variables, so we now do for function for 3 variables where f of u vw is differentiable function of u vw and u vw are functions of x. Then we have del f by del x is equals to del f by del u du by dx, del f by del v by dx, and del f by del w by dx. In the similar manner what we had done earlier, and we'll get the partial derivatives as we see here, and the total differential will be del f by df is equals to del f of u du, f of b dv, f of w dw. So we now do one example for 3 dimension. It's a simple example. So again in 3 dimension we have the Cartesian coordinate system. So we change the rectangular coordinate system x, y, z to Cartesian coordinate system, spherical coordinate system, sorry, and it's r, theta and phi, and it is defined by x is equals to r sin theta cos phi, y is equals to r sin theta sin phi, and z is equals to r cos theta. And we need to find 9 partial derivatives, and we also need to show that this relation holds. So let us try and find the partial derivatives. So we first find del x by del r. So when we differentiate this with respect to r and theta and phi taking constant, so this will be sin theta cos phi, simple. And again if we differentiate del x with respect to theta, let's see what we get. So here this will change, other two are constant, so r sin theta will be cos theta sin phi, and similarly del x by del phi will be, so here we have cos theta cos phi, so this will be r sin theta sin phi, but there will be one negative sign here. And similarly we can find del y by del r, it's already done here. So del y by del r is, again we see it will be sin theta sin phi, and del y by del theta will be r cos theta sin phi, and del y by del phi will be r sin theta cos phi. Similarly, del z by del r is cos theta, del z by del theta is minus r sin theta, and del z by del theta is 0. So now as we have all the partial derivatives, we find for del r by del theta. So simply if we solve for r, theta and phi, so we need to find r, theta and phi here. So we'll see. Let's see here, r square is equals to, we'll get x square plus y square plus z square. Simple equation solving. If we try, we'll get it. And theta will be cos inverse z by r, and phi will be tan inverse y by x, where x greater than 0. So we now find del r by del x. So del r by del x is x root over x square plus y square plus z square, simple as we had done earlier, and this is sin theta cos phi. And again del r by del y is sin theta sin phi. Simple calculation will get that. And del r by del z is cos phi, and del theta by del x will be so we have cos inverse. So for cos inverse, first we need to find this value, and it's 1 by 1 minus z square by r square, the formula of cos inverse, and there will be a negative sign, again one negative sign here for this, and del r by del x. Again, if we differentiate, we get z r square minus z square x by r square, z x square plus y square x by r square, r cos theta r sin theta cos phi, r root over r square sin square phi, which is, so this and this and this gets cancels. R sin theta and r square sin square theta whole root over gets cancelled, and we see this r and one r get cancelled, so we have cos theta cos phi by r. And similarly we can find del theta by del y and del theta by del z. So after we have all these things, we go on to prove the equation. Similarly we can find del theta by del x and del theta by del y as follows. So we have the equation del x by del r by del x plus del x by del theta by del x by del phi by del x, and after putting the values what we had got, we get del x by del r is sin theta cos phi, del r by del x is sin phi cos theta, del x by del theta is r cos theta sin cos phi, and cos theta cos phi divided by r, and here. So after simplification we find sin square theta cos square phi, cos square theta cos square phi, and sin square phi. If we take cos square phi common, we get sin square theta plus cos square theta and sin square theta. We know that sin square theta plus cos square theta is 1, and so we get cos square phi plus sin square phi, which is 1, and it's the RHS. Thank you for watching this video. For any queries, join my group in the description, and here you can find the soft copy of the notes of the lecture and update of the next lecture. Do like and comment and share with your friends. Thank you.